All right, while we wait for the rest of the audience to gather in the main area, we
short description. And what makes Wikidata a knowledge graph is that each item is connected to a list of statements. Statements have properties, for example, here, educated at, referring to Douglas Adams, and then values. Values can be textual values, numerical values, or even other items on Wikidata. So it creates that link, this connection between all the data on Wikidata. So this connection makes Wikidata more accessible for humans, but also for machines, where they can hop from one item to another, aggregating all the information and gathering the information that you're trying to look for. So what makes Wikidata special? It's collaborative, you can be part of it. It's a more nuanced modeling of the world, as we saw earlier. And it focuses on verifiability, where the statements on Wikidata are linked to external trusted sources. It's multilingual, it supports over 300 languages, and it's highly connected to a lot of external resources. So from books to museums to cultural heritage institutions to even other Wikimedia projects like Wikipedia. So basically, Wikipedia is a list of articles where you can access the article, read all the information on them. But Wikidata is more accessible through machines. And basically, you use Sparkle for that. Sparkle is this query language for Wikidata that allows you to do all types of functionalities on Wikidata. So from filtering information, from hopping from items to another, aggregating all the information until you get a table that what you're trying to look for. So basically, it's like SQL, but for knowledge graphs. But now with the popularity of generative AI, we're looking into solutions to make Wikidata also accessible to generative AI applications that rely on information, textual information that you can find on Wikipedia, but less reliant on knowledge graphs like Wikidata. So why do we actually want to create that link between Wikidata and generative AI? To better understand this, I thought I'd do a quick comparison between knowledge graphs and generative AI in terms of how they provide you with information. So in terms of correctness, knowledge graphs have human verified information, they have explicit information, and they're reliable. However, AI models produce their responses based on statistical patterns, so they may produce errors along the way. In terms of completeness, knowledge graphs can provide you with a complete list of information when you request that list, whereas AI models are limited to their recall capabilities. So when you ask for a list of items, they may miss some information when they're providing that list. Knowledge graphs are very easy to update with new information. However, generative AI models are bound to their training data. They're limited to that data, and they're really hard to update with new information and training them again and again. Knowledge graphs are transparent, they're traceable, verifiable information. It's easy for users to go to the information and extract where the information actually comes from when they're querying the database. Whereas generative AI, they function as a black box, basically, and they have non-transparent processes of how they generate a response. The only good side of generative AI is that they're very user-friendly, they have natural language interfaces. However, with knowledge graphs, it's more complex than that because you need to learn the syntax of SPARQL, you need to know how things are connected on Wikidata to be able to access the information. So this is where the project that we're working on comes in, the Wikidata embedding project. It's basically trying to find a link between AI models and Wikidata. And we do so by creating an open source vector database on top of Wikidata. And by creating that vector database, we enable semantic search on Wikidata's data and improve accessibility. And we also encourage the open source AI community to build projects with Wikidata. So what is a vector database? I thought I'd do like a very quick introduction to how we prepared the vector database and how basically you can use it. So the way we prepare it, we basically take each item from Wikidata. For example, here we have an item for orange, the fruit. We pass it through a large language model, which will then transform it into a vector, which we can consider it as like a mapping to the vector database or like a coordinate of where the item should lie in the vector database. And here we have like a 3D representation of a vector database. And the coordinate basically takes into consideration the meaning or the context behind the item. So when you map the items to the vector database, you can see that they cluster based on those meanings. So for example, orange the fruit clustered with other fruits, whereas orange the color, even though they have similar labels, it's far away from that cluster, clustered more with colors. So simple example. But now when we create that vector database and map all the information into that database, we can then perform semantic search. So the way it works, we take a query from the user, either a question, a sentence, any natural language that has enough context. We pass it through the large language model, which will then transform it into a vector and map it to our vector database. So the mapping basically tells us where in Wikidata, where in the information we can find context or relevant info that is basically relevant to our question, either tries to answer the question or basically leads us to somewhere in the database that can help us explore further to answer the question. So like a quick example here, if we look for which animals can be pets, it leads us to somewhere close to dogs, cats, animals, something like this. So now that we have the vector database, we can then perform retrieval augmented generation, which is basically a fancy way of saying that we want to provide AI models with external information so that they could use that information to respond to users rather than using their internal weights that have been trained with the training data. So the way it works with Wikidata and the vector database, we take a question from the user, we use it to query the vector database, get relevant information, get relevant items from Wikidata. Then we query Wikidata to get the latest information of those items. We give them to the large language model, then the AI model can reference these information and respond to the user accordingly. And also the AI model can then provide references to the user, for example here. This is like a really simple way of doing retrieval augmented generation, but there are many more advanced ways of doing that. However, with retrieval augmented generation with Wikidata, we can reduce misinformation because in that way the AI model is referencing information from Wikidata instead of using its internal weights, and therefore minimizes errors. It reduces disinformation because the AI model can provide links to the user as it's generating responses. So the user can trace back where the information comes from, verify that the generated response aligns with the data on Wikidata. It ensures freshness because in that case the AI model is referencing up-to-date information updated by the community. And it amplifies underrepresented knowledge because contributing to Wikidata would have a stronger impact on generative AI, instead of trying to create a dent in the large amount of training data that we don't even have access to. So to better understand vector search, I thought I'd compare it with keyword search and Sparkle, which we're familiar with, to understand its use cases and in which cases it can be basically used. So keyword search and Sparkle, they're very precise. They give you exactly what you're expecting. However, vector search can be a bit loosey. They may provide you with items that are not as relevant to what you're looking for. However, with this type of loosiness comes a wider scope of vector search, because in that case, vector search can be used for discovery, for exploration, for finding information that you might have not thought of as you're doing your exploration. In comparison, keyword search have a very narrow scope because they're only basically used to find information that you already know of. Sparkle has a wide scope because of all the functionalities it provides with counting, passing through the properties, and so on. Vector search handles ambiguity because it takes into consideration the context of what you're searching for. However, keyword search struggles with that because it can provide you with items that have similar labels but completely different meaning. With Sparkle, you can control that ambiguity by adding more filters to the query. The only downside of Sparkle, as we saw earlier, is the syntax. Being able to write proper Sparkle and knowing the IDs that you need to query on or how Wikidata is structured. However, vector search and keyword search both have natural language interfaces and they're easy to use. So this is the vector database. If you're interested and want to learn more about it, you can scan this QR code here. If you want to try out the vector search, you can go through the link right here. It's also provided in the project page. And if you want to create projects with the vector search, send us an email, let us know what you're working on. We'll be happy to know what kind of projects you create with it. So this is not the only project I wanted to share. There's also one project that we've been working on, which basically tries to combine the exploration aspect of vector search with the precision of Sparkle, which is the Wikidata MCP, or Model Context Protocol. So Model Context Protocol, if you're not familiar with it, basically it's a standardized way of providing AI models with tools, with functionalities or external resources. Basically, you write your own functions, You provide them to the AI model that they can make use out of these functions and get information. So one very simple example of a weather MCP that takes in a location, a date from the AI model, and provides the model with temperature so that they can answer the user accordingly. What's really good about these MCPs is that they're very easy to set up because they're standardized, and you can switch out the model with anything that supports basically tool calling. So in the case of the Wikidata MCP, it basically provides the model access to Wikidata's API directly, to the vector database for exploration, and to the Sparkle query service for executing. Here we have, if we search for Nobel Prize in Physics, we can see that keyword search provides you with exactly that item and other items that have a similar label. But in that particular case, vector search also provides you with examples. So in that case, you have examples of English physicists who have already won the Nobel Prize. Neville Francis Mott. So property search is basically the same exact thing, but trying to find properties on Wikidata instead of items. So if we search for a word received, keyword search provides you with exactly that, but vector search provides you with other examples, nominated for, winner, things that are similar to a word received, basically. We have get entity claims, which basically lists off all statements that are linked to a certain item on Wikidata. So if we look for the statements for Neville Francis Mott, we can see sex or gender, place of birth, and one of them being award received, Nobel Prize in Physics, and more information on it. We have get claim values, which is basically kind of like an extension to get entity claims. It takes in an item, a property, and lists all the values, but in this case, it includes also references and deprecated values if they're missing. So in this case, we can see if we search for Neville Francis Mott again and a word received, we can see the same value, Nobel Prize in Physics, but also a reference, which is connected to the Nobel Prize official website, so where the information came from. And finally, we have execute Sparkle, which takes in a generated Sparkle. So for example, here we have a Sparkle for getting physicists who have won the Nobel Prize and have country of origin Germany. And it provides you with the results from the Sparkle or error messages if it happens. So there's a lot of use cases for the Wikidata MCP, one being Sparkle generation, which we saw earlier. There's question answering, which is kind of like the same thing, but providing the user with an answer rather than a Sparkle query. We have cross-database integration, because we saw earlier that Wikidata is linked to a lot of external resources. So this MCP can be considered as a hub connecting all these resources into one resource. You can use it for fact-checking, particularly with the references that are available on Wikidata. And you can use it for continuous research conversations. So you can follow up with questions with the AI model, doing ongoing exploration, fixing what's missing, and so on. So this was the MCP. If you want to learn more about it, you can scan this QR code here. And if you want to integrate it to your AI client, you can use this link right here. Also, you can find it in this QR code. And make sure to add /MCP if you want to connect it. And yes, this is all. Thank you so much. I'll make sure to add the QR codes as well. Do we have any questions?
Anyone has any questions? One?
So yeah, I had a question about vector database. Is that all completely like built in-house from Wikimedia, or what is the structure of it? Yeah, or do you guys use any other existing open source database?
I couldn't hear fully. You're asking which, like, what are the technologies basically that are used for
Yeah,
creating?
behind the vector database. Yeah.
So let me go back to. I didn't add the technologies; they're included in the page, but just for like a quick general information. But basically, the AI model that we're using is developed by Gina AI. It's the embedding V3 model. It supports over 100 languages, and it's available on Hugging Face, so you can download it and use it. The infrastructure for the database, we're using, we have a partnership with DataStax, who are hosting the vector database for us, and they use Cassandra. This is what it's called, basically.
Thank you very much.
Thank you for your presentation. I have a question. Does Wikidata improve the accuracy of generative AI?
Does Wikidata
improve the accuracy of generative AI?
Technically, yes. If you're comparing it with basically like standard LLMs, I mean, of course, it depends on the LLM. It depends on the domain that you're trying to look for, because Wikidata is like general domain, but at the same time, it really depends on the community and what they care about to add to Wikidata. So basically, what's special about Wikidata is because it's a knowledge. What's special about Wikidata is because it's a knowledge graph. You can do all types of like complex queries with it. Questions that you might have that are not like directly available on Wikipedia, for example. Filtering with like dates, with categories, things like this. So once you have like a question that is that complex, you can then use Wikidata to get these responses, and the LLM can then use that response to answer the user.
Good. Any more questions? There's one more.
Thank you for a very nice presentation. We saw that knowledge graphs and the vector databases has their own limitations, so most probably to complement each other, it's good to combine them for a particular use case. Based on your experience, which is better to do? To start with querying the knowledge graph and then do query embedding, or vice versa?
I didn't quite hear what you...
Okay, if we combine in a use case vector databases and knowledge graphs,
Right.
And now we want to retrieve something for RAG, retrieval augmented generation.
Yeah.
Should we first query the knowledge graph or vector database?
Oh, okay. So that's a good question. For example, here you have the MCP. It's combining both, and it's providing these functions for the AI model to be able to query both. And in this particular case, the AI model chooses what to do. So you just simply give it the list of functions, you ask it a question, and on its own, it decides that, I don't like the word decides for generative AI, but it picks a function, gives it the parameters, and then gets the data to then continue. But in case you don't want to use the MCP and give it all this functionalities and rather like make it simple with like the retrieval augmented generation, it really depends on the use case. It depends on it. It's better to like test out things, see what makes sense for you, for your use case. The easiest way is to start off with the vector database because it helps you explore information. It gives the AI model like a subsection of Wikidata to then do further explorations. And when you're doing like Sparkle query with generative AI, if you don't provide it with information from Wikidata from the beginning, then it's not going to be good with generating Sparkle. It's going to like very likely hallucinate information and assume that in this particular domain, this is how information is connected. And it's most likely not the case. So basically, when I use the MCP, I like to prompt it to search with the vector database first, explore how things are connected, and then generate the Sparkle.
All right, thank you. We got time for one more question if there is any. One last question, yeah. There was another hand somewhere, another one there.
Do we know if the big guys are using Wikidata in any way, and if so, how?
That's a good question. It's I try to like, because I was curious as well. I don't know if they're using Wikidata or not. As far as I know, they're not. I mean, in a way they are, because when you ask ChatGPT, for example, to generate a Sparkle query, it gets the IDs most of the time correct. The structure, not correct at all. But I mean, that kind of says that they're using maybe not Wikidata directly, but pages that are talking about Wikidata. But they don't share that explicitly. One paper that I found that uses Wikidata from Qwen, they basically developed, I forgot the name of it, but they developed a browser tool with AI to like, I think it's called WebTailor, to like explore pages and aggregate information, like a better search tool. And it uses Wikidata for exploration because it has those connections that it's trying to look for.
Thank you. We have one more question here.
First of all, thank you for introducing the MCPs. I don't think that people talk about it enough for the MCP servers. I wanted to ask you about the Wikipedia MCP. Does it work as a multi-server MCP client, and how does it choose between which tool calling should it work with in order to get the information you requested from the query or the prompt?
I didn't get the last part. Sorry.
How does it choose which tool or dataset call to choose between on the multi-server MCP client?
So basically the way the way the MCP works is that you create functions, just standard functions with Python and whatever, and you write descriptions for these functions, like doc strings. And every time you query the generative AI, you provide it with a list of these tools with the doc strings, with everything. And on its own, it realizes that, these words again, but it like makes a decision of like, okay, you know, basically with the recent reasoning models and like tool calling models, they reason and say that, okay, I want to run this function right now because it's going to help me with these parameters, and then get the output and then move on with the reasoning. So you can explicitly tell them what to do. I personally like to, as I'm prompting it, giving it a workflow, because it misses sometimes, but technically the way MCP works is that like you give it the tools and it just makes the decisions on its own.
It's like magic. All right, big applause. Thank you, Philip. Thank you very much for this informative and amazing session. I'm always fascinated by MCP and what's going on in the AI world. And we will not stop here with AI, because the next session will be talking more about what's AI doing in the job. industry in the job fair? Is it taking away our jobs? Is it not? Is it contributing to create new jobs? Or what's happening there in terms of clashes with thoughts and perceptions in schools and everything? But without taking more time, I would like to welcome with a warm applause Silva Bashlari to give us more details on this wonderful session.
Do it, Bob. Also the thing for the thing, for this. Yes, please. Problem. It's a USB-C, so if you have another USB-C charger, it would be awesome. Are you bored already? Or how are you surviving after lunch? Not. I'm also sleepy myself. Okay. So, I am in low battery. It's okay, continue. Just a second. I need this. I just need also the clicker thing. Nu catete? Posso combater ele, fica. No, we're not. Just a second. Does someone have a charger that has a USB-C plug for my PC? Then I'm going to be ready. Thank you. It's my fault. I have the Italian plug, so it doesn't fit. Okay, cool. Thanks. Okay, now I'm ready. Hi. Sure. Okay. So, hello, and this works. Okay, this is me, yours truly. I'm going to talk about the future of work because of AI, and it's not going to be one of those things where 1 million jobs are going to be lost because blah, 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 which is so typical of investor talks or people you see on, I don't know, Instagram or in Albanian TV. So it's actually much more complicated than that. Economists don't agree on what's going to happen. There are multiple schools of thought when it comes to what's going to happen, and it's a good idea to look at things critically. So there are various theories, whether they are in a theoretical level, in an analytical level, or in an empirical level, and we are going to try to see a few of them together so that you can understand what are the different schools of thought with what's going to happen to us. I am a data scientist, but I try to bridge the gap between social, economic, and the computational fields. I'm a tech community builder in Albania, and I'm a total accidental engineer. So that's about it. We're going to talk about the future of work, for which I've been writing for the past 2 years and a half. And I know that you may have, I don't know, when we talk about the future and you think about utopic or dystopic visions, we tend to think about Huxley or Orwell. I'm sure you might have heard those stories. But we are going to situate ourselves in Berat, which is a city in Albania. And I'm using Albanian storytelling in order to understand these concepts and to make them clear to the wider public. Once this work is done, I'm going to make it free and available. I'm going to share it. And today we're just going to stop at a few points because this is a work spanning September 2023 to December 2024 and this past year of writing. So there are many, many topics to be discussed. Now, the question that is always posed is, are we facing the end of work as we know it? Like, is work done? Is that what's going on? And you often see news posts like this one. For example, Are we losing completely our jobs? A huge chunk of the job market is ending, yada, yada, yada. Sensational articles to get you to freak out. That can happen, but let's take a look at data. So this is data coming from the International Labour Organization, and we can see the unemployment rate, so the rate of unemployment, actually progressing from 2000 to 2025. And you can imagine why Kosovo in 2000 had huge spike in unemployment, but there is no long-term trajectory of unemployment dramatically increasing. So the data say this. Then you can say if we're measuring unemployment correctly or not. There's a lot of arguments to be made. What we should instead focus on is something else. And this is not just something that we project in data, but like David Autor, which is one of the best economists there are at the moment in the States, says it very clearly. Even in the 20th century, as women were entering the labor market, we did see unemployment fluctuate cyclically, but we see no long-term increase. But we all feel that something is going wrong in the job market, especially for young people, right? Like how many people have trouble finding a job? Okay, those two people, get them a job. Okay, no, it's not that. In general, there are problems when it comes to the labor market. And we have to talk about a new concept, which is well known among economists, but not well known among the wider public, and it's called underemployment. Who's heard of underemployment? Just you, okay. And you, but you heard my presentation, so it doesn't count. Okay, so underemployment is actually what we're experiencing, and it's a big problem if you don't know the word, because if you're experiencing something but you don't have the word for it, you're in trouble to organize politically. So underemployment, it can be time-related. For example, you want to work full-time, but you can't because all the offerings in your profession or jobs that you get are part-time. Skills-related, you are afraid that you are working in positions that require lesser skills than you actually have. And wage-related, when you get paid less, not than the ideal wage, but rather than other people who do the same job with the same skill set as you. And this is happening a lot right now, and this is destroying, let's say, the quality of jobs that are available. So even if, as we saw in the previous image, we don't see a long-term trend in unemployment, we do see underemployment coming up ever more often in all its three forms. But the question still remains, why are there still so many jobs? There's a famous paper on this, like with all the technological development that we have encountered, why are there still so many jobs around? And there are many reasons, but you can think of the ATM case. When the ATMs were invented, they thought that was the end of the job tellers, of the bank tellers, right? What did they do at that point? They just counted money. That's all they did. In fact, their profession changed. And if we want to observe, it went from 500,000 to 550,000. This is in real terms. Then in nominal terms, there was a decrease. But it had a modest rise. Why? Because if you had more ATMs, they could do other sorts of tasks in their jobs. We had more banks available, and therefore they could hire more people. This is called the complementary effect, when technology complements your job and therefore makes you more productive, or it allows that company to open more branches, or that entire sector to grow. However, there is also the substitution effect. Basically, your jobs get substituted by technology. This example should not be taken as paradigmatic. It doesn't happen all the time. There are specific sets of conditions that need to be fulfilled in order for such a thing to happen. Now, the thing is that there are these two forces, right? So there is the complementary force and there is the substitution force. And they don't always go on one direction. Up to this moment in time, the complementary force has somehow won, okay? We don't have a loss of jobs completely. We're not living in some idealistic society where we're all getting paid to do nothing and explore the space or something, though some people were exploring the space earlier this morning. And our jobs aren't completely substituted. However, people say that this time it might actually be different. Whether that is the case or not, there is huge disagreement. So there is this guy, for example, Daniel Susskind, he says it's the end of the world of work as we know it. Because what does it take for the complementary effect to win? you have to have the productivity effect, you have to have the bigger pie effect, and the changing pie effect. So what does this mean? It means that whatever technology gets developed, it has to make us more productive. You have to have the economic pie increasing, and you have to have the economic pie changing. That means you have to have new professions, new jobs available. All these three conditions have to be fulfilled in order for the complementary force to be the one to dominate. So what do we have to this point? As I said, we have two different forces. You have technologies that substitute workers, and you have technologies that complement workers. Up to this moment in time, we've observed that most of the jobs for the totality of the labor market were such that the complementary effect did manage to surpass that of the substitution effect. And not in every profession, because as we saw, you had the changing pie effect. You had new jobs, the economic pie did get bigger, and we have observed that, and the productivity effect that we got more productive. Now, the problem right now is that the incentives of all potential parties in the economic system are to substitute workers. They are not to complement workers' jobs. And there is this paper from Brynjolfsson, he rightfully calls it the Turing trap, which is basically a situation where machines substitutes for women labor, but workers lose their bargaining power, wealth concentrates within those controlling the machines, and the society gets stuck in a bad equilibrium. He's not, I don't know, communist or something. He's some American economist, okay? So this is not like, ooh, what's going on? This is already happening, and it's like common knowledge. And he calls this the Turing trap. And the problem right now is that we are stuck at this particular point, and he calls that this is the grand challenge of our society at this moment, is not to be stuck at the Turing trap. However, what he observes is that technologists, business people, and policymakers are all aligned to ensure that we develop only such technologies that substitute for workers, AI in particular. And AI is such an umbrella term. It has many, many things. For those that followed my workshop yesterday, know more about it. But the point is that you have AI that is being developed in one way. There are many, many ways to do AI. It's not just LLMs. LLMs are great. They can have many use cases, but it's not just that. So when you talk about the grand amalgam of technologies that can be developed under this bizarre name called AI, the ones that are predominantly being developed are those that substitute for workers' jobs. And all these different factions of society are aligned for different reasons, as you can see, to ensure that that takes place. And that's a problem. That's a big problem. And this is his graph. He has given us no ideas of the percentages, but according to him, those are the tasks that machines could automate. Those are the tasks that humans can do, and these are the new tasks that humans can do with the help of the machines. Now, it's very weird for such a mathematical economist like himself to not give any sort of percentages whatsoever on graphs, but clearly the idea was that we have such a new wide array of tasks that hasn't been explored at all. And there are many reasons for this. My best guess is the fact that we are stuck on such a fierce competition, and it sounds like a survival race, right? Like you just have to grow, 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 otherwise you die or you get bought. And so there is no space to go anywhere outside the rail lines that are already constructed. So yeah, and that's not cool. Now, the thing is, all of this is sold under the idea that let's just develop the AI we have right now because anyway, it's making us more productive. How many of you think that AI is making us more productive? Okay, it's not. And this Mon Amour, it's from Hiroshima Mon Amour. If you haven't seen the film, you should. We are not getting much more productive, statistically speaking. So even though you can see people on YouTube or whatever say, yeah, we're getting this much more productive, that's why we're firing workers because yada, yada, yada. That is not what labor statistics and labor productivity show. Since the 80s, we are stuck on something that it's called the productivity paradox. And Solow, one of the greatest economists of our times, he said, we see computers everywhere except in productivity statistics. And let me convince you. I want you to see this thin line, this one right here, which is of the world labor productivity, the rate of growth. So productivity is not going down, but the rate of growth of productivity is decreasing. What does this mean? In 1970s, every year for the entire labor of the entire world, productivity was increasing for about 3.5% year by year. Right now, not right now, 10 years ago, but in 2015, productivity was increasing at about 2%. So the rate of growth of productivity is actually decreasing. And that's a problem. Like in the 70s, we had technologies which were much more advanced than in 2015. I mean, I guess that's like common knowledge, right? So how is it possible that we are getting productive at a much lower rate than before? Like, that's strange, right? So this is a big problem, and now with AI, it's called the modern productivity paradox, and there are 4 schools of thought as to why that is happening. So if I leave you with one thing from this talk you had on a random Sunday, it's this. For every single economic phenomena that we are experiencing, especially in a moment like today, there are multiple schools of thought as to how to approach it, and so don't get stuck on some deterministic tale of, yeah, this is going to happen. Definitely not, and these are smart people, they know what they're doing. So, what do they think? There's people that think that we have false hopes. So maybe AI won't be such a grand technology as electricity, for example. Electricity was amazing. You could see in about 70 years, something completely drifted society off. While with AI and with ICT technologies overall, probably it may not be as big. And as you can see here, like again, look at this very thin curve, because for emerging markets, some different trends occur and there's more fluctuations. But you can see in early 2000s, there is a little bump there when internet got commercialized and expanded on scale, but definitely not what we had before. So maybe we have false hopes. Maybe it won't be as big as we think it will be. Then there are those that think we have implementation and restructuring lags, which means that we will see the gains in productivity, but it's going to take a lot of time. And by a lot of time, that can be 100 years, 200 years. And we have to redesign, for example, we have to redesign our factories, we have to redesign our cities to be operatable by machines. For example, you can have a very cool AI technology, but if you put it on a factory that it's meant to be operated by people, you're not going to really see productivity gains. So these people say it's just going to take time and redesigning. Other people say we have concentrated distribution and anticipation. Fancy words. What do they mean? We are using AI to create ads on social media. So all the grand technology we have, we're just producing ads for some people to buy some particular things for the house they don't even need, right? That's not productive. And there are those that give the mismeasurement argument that we are measuring productivity wrong, we should be measuring differently because, for example, you don't pay for ChatGPT, right? Well, some people pay, but a lot of people pay, but you don't pay for certain services, and perhaps the way we're measuring productivity, it's not reflecting the true value it has to people. So these are the 4 arguments at the moment. And then there are those that think, again, we are developing the wrong kind of AI. I highly encourage you to check out this guy, Daron Acemoglu. He's the Nobel Prize winner in economics from previous year. And he calls AI a so-so technology, like literally in those terms. Because what he says that the recent technological change has been biased towards automation with insufficient focus on creating new tasks where labor can actually be productively employed. The consequences of this choice have been stagnating labor demand, declining labor share in the national income, and raising inequality and the lower productivity growth that we saw. And as I mentioned, he calls it a so-so technology. What is a so-so technology? Something that shifts the costs from the companies to the users. When you go to the checkout desk, it's not that we are getting so high-tech that we don't need any more people to work in supermarkets, it's that you're doing the job. So does that mean technological advancement and productivity growth? Highly unlikely. And there are guys that say, well, it has nothing to do with automation. This one, Aaron Beninav, he says, none of this has anything to do with automation. What has been happening since the 70s has been economic stagnation, where what we did, we saw a worsening economic stagnation from before due to two things: overcapacity and underinvestment. What does that mean? Long story short, we were doing manufacturing before, right? Because I can see a pretty young crowd. So we had all the growth that we experienced post the Second World War was mainly based on manufacturing and actually reutilizing the advances that were made during the Second World War into commercial products that then we can actually use. With globalization, everyone thought that we were going to produce different stuff every country. In fact, they were all producing more of the same. You had overcapacity, and therefore companies had underinvestment, and with a decline in manufacturing, we are stuck at an economic stagnation, and you cannot find the new manufacturing to boost the growth engine that it was for growth. So yeah, as he says, we have the replication of the technical capacities, international redundancy, and fierce competition for markets, which has led to no growth, no labor productivity. And he says automation can be a secondary effect, but it's definitely not the primary one. So this is where we're at. I realize it's very dark. That's why I made the slides red, just for creating the idea this is pretty, but it's really not a pretty picture. I'm very much concerned about the future. If you have to work for a living, like, it's gonna be tough. Like, for the people that have, like, I don't know, a lot of money from their parents or something, they're gonna be fine. But labor, I see labor and work as the central factor in society that determines the quality of one's life. And therefore, we should see directly linked with technological change. Technological change, especially AI, impacts other stuff. We have stuff with discrimination, we have stuff with identities, with competition, whatnot. For me, the primary impact of AI in society is directly related to work, especially when we are selling the story that we are becoming hyper-productive, but no one is seeing it. And these are smart people. They know what they're talking about. So what did I do as a final point? I compared what top-tier economists are thinking with the perceptions of young people in Europe. Because what becomes a political reality, it's not the best theory, not the best economic theory, the best empirical theory, but it's what people believe to be true. If you think X politician will win, you're less likely to vote for the other guy. So it's very important what is the public perception. And that's why people pay so much on ads. And so I asked people to define AI, for example. And funny thing, they define it more with human, think, computer, machine, which is not the kind of AI we're developing. We're developing the connectionist AI. Machine learning has nothing to do with human thinking. It is actually very different from that. In reality, that is the symbolist AI, old school AI, where we were trying to recreate the human brain. Right now, we are developing something that has nothing to do with how people think, and yet people think that's what we're developing. So that's called, we need better science communication, because seriously. Now, I also asked people if they think that we are going, how much more productive we're going to get in the next 10 years, and most people believe to be more. But when they are confronted with the reality of the data and the theories that I showed you, most people believe implementing lags, so that we are going to see the productivity gains. It's just going to take a lot of time. So this is, and these are data from young people in Albania, Kosovo, Italy, and a couple of other countries in Europe. So if I leave you with one message, the future is not deterministic, nor predetermined. There are different ways to develop it. There will always be different ways to develop it. You have to know it. You have to know them. You have to live. It's annoying. Like, you have to read so much. Like, where do you start? You know, like, you also want to exist and go out and have fun and everything. But if you're going to work, and you actually have to know what's going on to a certain extent. And you have to keep informed, even though it's quite exhausting to do so. So that's it. I will publish the study results when I actually have the final version of them, I hope sometime in the next 2 months. And we will see what young people in Europe think, especially in Albania and Kosovo, about the future of work. Thank you.
Okay, so we have a few minutes left for questions if there are any. Oh, there's one.
Hi, compliments on the presentation. So when OpenAI was launched at first, the AI scientists sort of predicted that AI is going to replace the, let's say, harder jobs or the jobs that are more stressful, and humans will be left doing all the artistic work or whatnot. Now, I am not a data scientist and I don't have the knowledge, so I'm curious to know how can we collect data in order to make these sort of predictions as correctly as possible.
Okay, so if I understood you correctly, and before I was judging the other people, like, why aren't you hearing the questions? You can't hear the questions from here, really. So, if I understood you correctly, you are asking how can we actually measure which kind of jobs are going to be replaced by AI, right? Okay, so we don't talk about jobs. That's what news people do. Economists talk about tasks because each job is a composition of tasks. And you can measure how many of those tasks are actually going to be replaced and can be replaced with the current technological advancement. And there are people, crazy enough, that have mapped all the jobs in the world. There is a data set called ONET, and they've mapped all the possible jobs that exist in the world with their entire task composition, and then economists take these data sets and they speak with AI people, and they measure for every single task what percentage of this task can actually be done by AI. And by the way, that guy I showed you before, like this guy, this guy, Bryn Jolson, he actually has made a paper exactly on that, and he said that no complete job, if a job is a composition of tasks, no complete job can be replaced by AI right now, because they're very complex, and this is taking away task interdependency. So just speaking in discrete terms, no concrete job can be replaced by AI at the moment, according to this guy. Do you believe that guy? I don't know. Yeah.
Okay, we have one more question.
Okay.
Hi, Silvia. Thank you for...
You have to scream.
Yeah, I will try. So thank you for the presentation. It was a very nice perspective. So saying that productivity is falling or is not increasing, it's quite a bold statement to make.
Yeah.
For example, especially if you compare today with 2000s. I'm more interested in how did we quantify productivity? Yeah.
Yes. Productivity is a well-known statistical metric, economic metric, sorry. So it's not like I asked people, are you productive? I didn't even do this graph. Like whatever graph I did, I labeled it as such. We measure productivity in different ways. A basic way is to take the GDP, so the gross domestic product, and then that is because what is the GDP? It's literally the output, right? The total output of your economy, and then you divide it by number of people in employment. So you have output per worker, right? So your workers in 1 year time frame or in whatever time frame you take, how much output have they produced? And before the follow-up, which I can imagine, they do measure even non-tangible things. They don't count just chairs, you know, like these are smart people. They know that we have to count services. They even count the impact of Facebook, for example. You don't pay for Facebook, but they count it as the value of the company compared to blah, 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 something else. So they do take these things into account, and people don't agree on much, but most people agree that the rate of growth of productivity is going down. Then why? That's various reasons for that. Yep.
Okay, we have one more.
Thank you for the wonderful presentation. It was very nice, and I especially love the public's perception. As a professional media scroller, I can say that I totally see AI as, recently as different, especially at the example you made, as different states, different companies making a different version of AI, that big tech is going to buy that, and it's going to be a whole big AI of Google, let's say. And all of this makes me think, and others think, that we are exactly in an AI bubble right now.
We are in a what?
In an AI bubble. So
AI bubble.
Yeah.
Okay, yeah, yeah. Okay.
So do you agree with this statement, especially with the stagnation and such? And if so, when is it going to burst?
Okay, there are different reasons why people think that we are in an AI bubble. So here I go again with schools of thought. You're going to hear that from me a lot. There are people that think that we are in an AI bubble because AI sucks. There are people that think that we are in an AI bubble because the way that the money is circulating in the economy from one company to its subsidiary to another subsidiary to back to another company they bought but gave some shares. So one argument is the money circulation thing among a bunch of companies. They buy and sell from one another and they're like, are they really investing in something or just circulating money around? There are other people that think we are living in a bubble because we are trying to develop as much AI as we can, but is it really useful for business cases? And there is this article from the New York Times, which is not, again, like communist, because someone said, oh, this is a very communist presentation. No, it's not. So, New York Times. And you can see that the companies are not benefiting as much from AI as they originally thought that they would. So there are different reasons to think of it as a hype. One thing is for sure is that we have a lot of, at least in the United States, a lot of the economical growth was based on how much money they had invested in the data centers. And there are varying percentages to that, but now they're freaking out because we are also in a race, you know, like on a world level, we are competing with different countries. AI is definitely here to stay. Like, I don't particularly find LLMs the most great scientific thing there is in the world, but it has some utility. The problem is, in my opinion, that we are giving, it all matters on how you develop the political and the economical relations. Then you can develop whatever technology you want. No one is going to stop you to do that. But if you already live in a country that treats workers like trash, then you're not going to get much of anything that you develop in any way. So could you say we live in an AI bubble? Depends who you ask. For sure, there is an over-evaluation of the AI potential, but it's for sure also here to stay because it has provided some value that you cannot go back. You cannot go back to a world without ChatGPT. It's already here. Things have changed, some things for the better, and it's here to stay. Is that the only trajectory of development? For sure not. Like yesterday, I'm sure you heard the talk. I don't know if you did, but there was a talk from another guy. He was talking about causal AI, which is causal inference as opposed to correlation inference, which is what we have right now. There are people that are working more on image recognition because you can get up to a certain point with speech, but the speech is limited, whereas we learn, even as babies, we understand the world by seeing. We observe the world around us, and then we develop speech capacities. So there's a million things out there. AI is here to stay. LLMs are doing some service. They're probably overvaluated, and we have to see how are we directing the economy because look at that graph.
All right, that's it. Thank you very much, Silva. Really interesting conversations, AI bubble, will AI take our jobs, and so on and so forth. Among other things, one thing that I noticed with AI, you can rapidly build products, which used to take way more time in the past. So if you have ideas, now you can put them out there in the market much faster. But there's also this vibe coding garbage that happens, so that's more work for engineers. Because people build prototypes and then they need engineers to fix them and to scale them. So new type of jobs coming up. But yeah, it's an interesting debate on this one. So moving on to the next session, this is going to be more of a show and tell session where we will have two students from the University of Pristina who are going to present projects in front of us. First of all, I'd like to invite to the stage with a big applause, Lerdi, to present Appointly.
Hello, everyone.
I'm Lirdi Salihi, and I'm really excited today to speak to you about our future. We have a product here, and it is called Appointly. Appointly, in this period of time, was made by these people over here. These are my colleagues. It's me, Lirdi, Yasin Avdio, Etret Hasoli, Marian Kolay, and Patlio Mehmeti. And we, as students and as citizens of our Kosovo, we saw some problems. And we've encountered a guy, and he's called Broski the Client. Broski the Client here looks a little mad. Wouldn't you say that? The reason why he's mad is because when he was making appointments, he had a lot of miscommunications. He was forgetting when he made an appointment. He was always tired of waiting on hold to make an appointment. But sometimes he was just like me. He was just too shy to call. But that's just not for Broski. Let's see statistics now. Insufficient scheduling slightly drains 30% of revenue. 12% of their time is wasted by managing calendars, while missed appointments can eat another 30% of income. 75% of customers now prefer online booking. You can see more on these pages here. But we have found the solution for that, and Appointly is the solution. You see here is Appointly. When customers go there, find their business that they want to do the appointment, they select it, and they basically make the appointment. They will be notified via email, SMS, so they will never forget. They will just see again. But for businesses, they will see the booking appointments every day, every week, every month, and they will have statistics. These are two main features that Appointly has. One is Chatly, our cute AI chatbot here that you can basically talk to and make the appointment, but also analytics, when you get real data from your business. But for technical guys out here, how does it work? It works the front end, it's basically React, Vite, Tailwind. For backend, we use Node.js, Supabase. Netlify functions. For AI, we use Grok, OpenAI, Twilio for SMS, SendGrid, NodeMailer, and for secure communication, MCP. Everything here is deployed in Netlify. But this Flusk, we learned so much about open source, and we used open source because it's good for us. And everything, as I said, is in Supabase, which is open source. We use React, TypeScript, Tailwind, Express. We use Bakelite, basically hashing the password. This is our schema here. This is the rough high-level design, which basically the business and clients go to the front end. Then you will be notified via the email sender API. You get the Netlify functions, which you get the SMS via the Twilio, which you basically have to pay for some of that, but you have some free trial, which we used. But also, everything is in Supabase, and you have the authentication via the Supabase. This is the MCP here, which basically uses two Netlify functions, one which we retrieve the syntax from Grok AI, and the other basically fetching everything from the database, calling the tools. That's why it makes it secure. But now I welcome you all here to Appointly. You go to Appointly, you select the business, you select the service, the time that you need to make the service, and then you'll be notified in the email and SMS. But we're humans, we sometimes make errors, and you can edit them. So for businesses out there, Appointly helps you grow. Why does Appointly help you grow? Because you go in Appointly, you see structured appointments. You can see and you can select somebody that makes an appointment. You can basically confirm it to them. You also have all your employees, which you can add your employees, edit them, but also add services. What service do? You have settings there if you work on weekends, and also the most important part of it is statistics, when you basically can see what days are your busiest and what time is your busiest. In Appointly, you can make appointments anytime and any place. Here you can see the AI chatbot. When you're basically making an appointment while chatting, you can see the user going here, talking with the AI, selecting the service that he needs, and giving all the information, so he will be notified via email and SMS. But also, it uses real-time data, and it has secure communications, as you saw in the diagram, which basically uses MCP for that. In Appointly, you choose a plan. You have three different plans. You have Basic Plan, Pro Plan, and Team Plan. All three of them have 3 months of trial, and it's actually, Appointly is developing over time. But why would you choose Appointly? You choose Appointly because of effortless 24/7 booking, AI-assisted scheduling, real-time availability, instant confirmation, and secure management. So you save time and never miss a client. Do you hear that? Time's ticking, start clicking. Thank you for your attention. Do we have any questions, or should I? Okay. Don't worry, you can speak. I will try to listen at least. Should I continue? Yeah. The question was, is it adapted to the businesses out here? I think so. Everything is going to AI and going to making simpler things. The reason why it's adaptive is because we're making it easy for them. Everything is in place. You don't have to call anymore and say, oh, I want to make an appointment, and when you go there, you have to wait in line till Veternej Katja. And that's what the reason is, because you go there, you see every appointment, and customers actually are getting tired of just going, selecting, or just basically calling something and saying, I want an appointment. So they just go here, everything is digital now. So they make an appointment, they will get the SMS, they will get the email, and everything will be adapted. We are developing so every business will make it easier for them. Thank you for the question, though. My professor out here.
Okay, there's one more and then testing. Okay.
I'm on a roll with questions. Okay, so thank you for the question. As I understood the question is it adaptable to every business out there? So can a doctor's office use it, a dentist, or can I even make a hair appointment at that in the same tool?
Yeah, basically it's for not every business. We understand that because every business has its difficulties. For example, the restaurants, you will have to know how many chairs they have and everything, how much place they have. But for doctors out there, for dentists out there, the health clinics, for how do you say it? Yeah, physiotherapist, you understand me? So yeah, it's easier to adapt, but we're looking to adapt everything there, so it's a product in development, so that's why. Thank you.
All right, thank you very much. You made sure to scan the QR code if you want to have a look at it. So next to the stage, we'll invite with applause JRG to do another show and tell of an AI-powered app, which is more in the saving money space.
So, hello everybody, I'm Jared Shuni, and thanks to FLOSS Kosovo for making this beautiful event and giving us the opportunity to showcase Ruai Manshur. So, Ruai Manshur in English means save smart, and it's our application that helps people to save money in an easy and smart way. So smart saving and achievable dreams, this is the model. The problem is that sometimes the expenses are out of control. Many people don't know where their money goes, and they ask themselves, where is the money? Where did my income go? Some mothers have dreams like buying a car, an apartment, a house, or maybe even a smartphone. But those remain dreams. The question is why? Because they lack of a personal advisor. And this problem we're going to solve by introducing you to the first Albanian application that puts your finances in order through AI. So, Ruai Mentor has intelligent dashboard, transaction tracking, Finbot AI assistant, and saving goals, all these features in one. Manage, track, and save with ease. We created Ruai Mentor to be simple, so you have access to the dashboard, and you can add your expenses with only a simple few taps. So you can save and achieve goals, track and analyze, and have easy charts, so no complexity. So Ruai Mentor has no complexity, and it's very simple. The final part, or the main thing in our app, is Finbot AI Assistant. So meet your virtual financial advisor, Finbot, which our group built it in open source technology. We created it friendly and to give you real tips through having your data like, for example, it says, hey, you spent today 5 euros on coffee. If you spend only 3, by the end of the month, you'll have 60 euros in your pocket. Or maybe even you can ask Finbot, hey, I want to buy some sneakers. And Finbot will show you the websites where there are the websites which sell sneakers from the cheapest to the expensive ones. So it gives you real-time advice when you spend and smart answers to every financial question. So as I mentioned, we build it in open source so we can add features day by day and new things and update it. What does Ruai Mentor offer? It offers you a complete dashboard, detailed tracking, smart goals, and advanced reports. So you can gain deep insights into your financial habits through personalized and easy to understand reports. So it will make your habits with money even better. So firstly, we thought Ruai Mentor to be only for students because students struggle for money. But we thought, why not for everyone? So we created it for young people, so young people can save money for their new experiences, for families which plan a future, and for professionals who want smarter investments and long-term wealth through AI. And your question by now is, why to invest in Ruai Mentor? I have three strong reasons. The first one, we are touching an untapped market, so we are the first ones in Kosovo to do this. The second one, we are using advanced technology. We're using AI, we are using open source, so this makes us different. The third one, we are a very dedicated team. We are a group of students of computer science, University of Pristina, in Fashimina, which are eager to grow this app and to make it even better in the future. So, in this moment, I want to thank our Professor Eliot Betucci for mentoring us since day one. Till yet, Ruai Mentor is not just a finance app. It's a big step forward for the future finances. So don't hesitate and go visit our website and and start the journey from today. Thank you. So, if you have any questions?
Jerzy, thank you. All right, question time if you have any. Don't be shy. It's always an improvement to see students improving, pitching their ideas in front of an audience, so that's... you left the audience speech?
I think they like the application.
All right, there's one.
First of all, thank you for the presentation. I have just one question for you because I've seen your project even some days before, But my question for you is, what are some new features that we can expect for you to build in this website?
So you mean the features you can use in our application? Yes. We're thinking when we improve our application to make like connections with the businesses and to add a new feature where businesses advertise their sailings and their, for example, when they have Black Friday, for example, and they set their products with lower or cheaper prices. So we add into the Finbot, so Finbot tells you, hey, for example, sneakers in this weekend are cheaper. You can buy them because you have like this money or something. So we're going to improve. Thank you.
All right, good. Thank you very much, Jerzy. Big applause. All right, so remember, this is SFK. It's not a startup competition. It's not a business competition. It's a show and tell to showcase to you what students are able to build with open source technology, and to hear questions from you to improve them and so on. Just a small advice, try to go away from this, we are the first in Kosovo. Just try, I hate that. When businesses use it, when people use like first in Kosovo, we're last in the world. So just focus on something else to be more competitive in the market. All right, so we're gonna have a short coffee break until 3:15. And then we're gonna continue with a session which is focused around showcasing another open source project. And we will be sharp, 3:15. Enjoy your coffee break and see you soon. Thank you.